Good morning, doctor. Have you come to a conclusion regarding my sister, sir? I'd really like to know what happened so I can properly mourn her death.
Sure, son. Let's lay out the facts first. Your mother said that your sister was washing the dog with some flea dip, known as Fleacide. By the time your mother got home, she found your sister vomiting and she took her to the hospital a couple of hours later, but by then it was too late. Her technical cause of death was hypoxia or lack of oxygen.
But sir, if you please, could you explain why she lost the ability to respire in the first place?
The flea dip your sister was using had an ingredient called rotennin, which is usually a harmless plant root, but it seems your sister must have consumed an exorbitant amount of it, which was quite pernicious.
How so, doctor?
Well, in order to understand what happened to your sister, you need to understand cellular respiration.
I believe that I understand the functionality of the glycolysis. Could you correct me, sir, if I am mistaken in this comprehension? This first step of cellular respiration, glucose splits into 2,3-carbon sugars. In the process, a net gain of 2 ATP is achieved along with 2 molecules of pyruvate and 2 NADH. But where do these molecules go?
The pyruvate travels to the Krebs cycle. There is a series of rearrangements of carbon and other molecules. Carbon dioxide is released from the cycle many times as the pyruvate reduces from a 6C molecule to a smaller carbon molecule. ADP enters the cycle and joins with a phosphate group to form ATP, and NADH and FADH also are formed as a result of this cycle. These electron carriers carry them forward to the electron transport chain.
Exactly how should that work, sir? And if you please, could you explain how it failed in my sister's body?
In the mitochondrial inner membrane, NADH and FADH drop off electrons. Carrier proteins accept full atoms, whereas the coenzymes only accept electrons, leaving an excess of protons on one side of the membrane. They travel through ATP synthase, which produces ATP. However, rotennin from the flea dip inhibited oxidative phosphorylation.
So, essentially, the rotennin binds competitively so that electron flow is inhibited, and therefore, there is no gradient to allow for the movement of protons which produce the ATP.
Exactly correct, my dear chum. It was sadly the rotennin which killed your dear sister.
Thank you, doctor, for your help. I can now mourn her.